Now we're looking at 3.5, and we're going to transform those basic equations we set up in 3.4. So we need to understand the transformations. And this, folks, is the full transformations. From the basic y equals b to the x, so b is the base, and x is the exponent, we can transform a graph by doing something here, 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 and here. And what we're going to do over the next set of slides is talk about each and every single piece, each of those letters, A, K, D, and C. First of all, let's look at A. Now, A plays a special importance to the graph. And the importance it plays is the following. If the A value is negative, so again, there's a negative number right at the front after the equal sign, it means that the graph did a vertical reflection. If you remember parabolas, we talked about in parabolas that if A is negative, it opens down. What that really meant was that the parabola had a vertical reflection. In terms of exponential functions, that's how we describe it. If this number is negative, we say that there is a vertical reflection. Now, that's only dealing with the sign. If it's positive, obviously there's no reflection. If it's negative, there is a vertical reflection, but that's only dealing with the sign. What about the number that could possibly be here? So the number has something else that it does. If that number, okay, so these mean absolute sign. That means that we're only looking at the number for A and not the sign. If the number for A is greater than 1, it means that the graph actually stretched itself vertically. So number, not the sign, is greater than 1. We vertically stretch by a factor of that number. Now, if that number, again number, not the sign, is between 0 and 1, that number that would be here before the base is between 0 and 1, that means that the graph actually did a shrink. So it shrinks. But when we express that mathematically, we say it vertically compresses by a factor of A. Again, that number and not the sign. So you will never see a negative in each of these. A negative would only mean there's a reflection, not changing any of these values. So again, we look at the number and not the sign. The sign means a reflection, possibly, and the number means either a vertical stretch or it vertically compresses. So we will look at examples that use actual numbers. Before we do that, let's move on to the next letter. K. Now K and D, you have to be careful. And I have them circled up here to tell you that it's opposite of the way they look. So instead of multiply by K, we're actually going to multiply by 1 over K. So we're not going to look at K, but 1 over K, folks. Now, that means we flip the number. We don't change the sign. We just flip the number. When you flip the number, that means we need to take it and literally flip it. And when we flip it, that number, if it originally was negative, it stays negative even when we flip it. And when it's negative, that means there is a, that's right, horizontal reflection. A horizontal reflection means the graph flips sideways. Now, another thing that the graph could possibly do is horizontally compress or stretch. Now remember, we're not looking at K, we're looking at the flip of that number. When we flip that number, if that number is actually bigger than 1, guys, then that's the same thing that happened with the A. That number is bigger than 1, so it must do a horizontal stretch by a factor of 1 over K. Now again, number, not the sign. If that number, when we flip it, 1 over K, is between 0 and 1, we can say that it has a horizontal compression. by a factor of 1 over k. So again, it would be the number next to x, and keep in mind, x must have a coefficient of 1 here, folks. That's the very first thing the equation always has, is that the x must have a coefficient of 1. That k is always found outside and separated from the x. So that k, we don't look at k, but we look at 1 over k. If the flip is less than 0, it's a horizontal reflection. If the flip, just the number, is greater than 1, it's horizontal stretch by a factor of 1 over k. If the flip is between 0 and 1, then it horizontally compresses by a factor of 1 over k. All right, next letter. D. D again, you have to look at opposite of what you see actually there. Okay, so again we look at D, and it has to be opposite because it is in the exponent and it directly affects the x. One thing to note again, reminder, x must have a coefficient of 1 for D to be valid. You can't just pick any D, and x must have a coefficient of 1. That means k was divided out of the number so that you could get the proper D value. What does D do? Well, if D is greater than 0, and what that means is you see in the brackets, in the exponent, x minus D, keeping in mind x must have a coefficient of 1, that means that the graph translates to the right D units. Next, if D is less than 0, that means you have in brackets x plus D. It means that the graph translates to the left D units. And again, we don't say negative D, we only use the number and not the sign. When you see this in brackets, means that it will go right. When you see this in brackets, it means it will go left. So again, up here in the exponent, we only deal with things that move horizontally. Here would be horizontal stretch or compress. Here, it moves either left or right. So everything up here is horizontal. And note, everything you see up here is actually the opposite of what the description is. Keep that in mind. Moving forwards, there is the value of C. What does C do? Well, if you see plus C in the equation, it means that the graph moves up C units. If C is less than 0, that means it's minus C, then the graph translates down C units. So I want you to understand is that C and A have to do with things vertical. A means that it stretches vertically and or compresses vertically, and the C means that it moves up and down, so again vertically. So the A and the C are exactly as you see them, and they convert vertically. How does this help us? Well, let's look at the next problem. Example 1. You're asked to graph the following function. When you're asked to graph a function, you need to follow the proper steps. The first step is to get x have a coefficient of 1. Step 1, you must see 1. 1 where? At the x. So always make sure that x has a coefficient of 1. We do that by removing that 3 that is located right next to the x. So this 3 we're going to divide out of here. And we get 3 times x minus 1. Keep in mind that when I expand this out, I will get 3x minus 3. Alright, now, how do we fill in the table? Well, first we need to know the basic. What basic equation are we going to use? Well, we're going to use y equals 2 to the x. Why? 2 is our base, so that's our base. X is the general equation that we're going to start with. So what x values are we going to use? Well, that is -2, -1, 0, 1, and 2. These are standard. Comma. And after that, you're going to find the y values. How do we know what the y values are? You plug it in. Plug these x values in for x to get our y value. 2 to the -2 is 1 over 4. 2 to the -1 is 1 over 2. 2 to the 0 is 1, 2, and 4. Next, what we're going to do is we're going to determine what goes in here. The -3 and the +1 have to do with vertical. The exponent has to do with the horizontal. So the green has to deal with the y's, and the red has to deal with the x's. So much so that when I write the equation out, it will always be 1 over k times x plus d, and the second part will be ay plus c. So again, let's write that out so that you have them. The k is 3. Flip it, it becomes 1 over k. 1 over 3 is this part times x, because that happens horizontally. And then instead of -1, it's opposite of what you see, so it's +1. This is the formula you will use to always do this. What you can do is identify what the a, k, d, and c are. So a, 1 over k, d, and c. A is -3, 1 over k is 1 over 3, d is 1, and c is 1. So we can apply those values into the equation, into the table of values. So here it is. List your a, 1 over k, d, and c, and use a and c. Think of Air Canada, flies up into the air, so that is vertical. And KD is Kraft Dinner. Kraft Dinner, when you put it onto a plate, spreads out horizontally, so this would be the KD right here. So this is how I get students to remember it, remembering this formula, Kraft Dinner formula and the Air Canada formula. Now what you're going to do is plug in, see this x, see this y. Well, this is our x and y that you're going to plug in your calculator. First plug in the x, so it's 1/3 times -2, which is -2/3, plus 1 will give you 1/3. Then -3 times 1/4 plus 1 is -3/4 plus 1 is 1/4. And that, folks, is the new coordinates that this transformed itself to be the new set of coordinates. Now keep in mind, it's not always going to be the same. It just turned out to be lucky for us. Let's move to the next one. Plug in -1 for x, and you're going to get 2/3. Plug in 1/2 for y, and you're going to get -1/2. Plug in 0 for x, you get 1. Plug in 1 for y, you get -2. Plug in 1 for x, you get 4/3. Plug in 2 for y, and you get -5. Plug in 2 for x, you get 5/3. Plug in 4 for y, you get -11. The last thing we have to do is convert the new horizontal asymptote. The horizontal asymptote is y equals 0. If I stretched it, it would still stay there. If I compressed it, it would still stay here. What happens though is if I move it up or down, it does not stay here. So the y is 0, plug in 0 for the y, that would be right here, we would actually end up getting y equals 1 because we're plugging it into here. The c value will always be our horizontal asymptote. Always, folks. The c value is the horizontal asymptote. All right, now that we have these points, what we have to do is we actually have to graph it. So there's the coordinates we had earlier, and we're going to graph it. Now, I have some rules about graphs, so let's talk about that. Normally, you would cover the whole area, but because I need these coordinates, I'm going to leave it here. Basically, ignoring this area, we need to see a graph that covers, now my rule is it has to cover 75% of the curve. 75%, and we're talking only half of the page, means that I need to cover almost all of it. I need an asymptote at y equals 1, and I'm going to need coordinates on the x-axis that are positive, so all the x values are positive, that's why it's on this side. And we need the y values that are at 1, and everything is underneath 1. So that's why the x-axis is so high up here, is because we're going to have everything underneath it. And then you choose a proper scale. Note that I use different So here's our horizontal asymptote. And notice that I use this many blocks to get to 1 across here, but I don't use the same going down. You don't have to. As long as it is the same horizontally and the same vertically, these two do not have to be the same values. Make sure you have arrows at the end. Make sure you've extended that asymptote as far as you can. And make sure it's a smooth, rounded curve. All right, next. Next, we're going to be asked to describe the transformations for the following equation. All right, very first thing we do is make sure that x has a coefficient of 1. So convert the equation so that x has a coefficient of 1 as such. Now keep in mind, you could always check to see that you expanded it correctly by expanding these values to, and you should get negative 2x minus 2. Next, we're going to look at a table. When we describe the transformations, the hardest part is making sure you cover everything. When I want transformations, I want to know all the different parts of the graph. So if I had to visualize it, I can visualize it via the information given. So I need to know what the basic equation is. I need to know if there are any reflections, any stretch or compresses. Stretches or compress. Translation, asymptote, domain and range. And this can happen vertically or horizontally. So we're going to talk about this. A reflection means that either the A or the K value is negative. Let's look at the equation. This is the red one we have to look at. My A value is negative 1/3. But before I do that, what's our basic? Well, our basic is y equals 4 to the x. So g at x is equal to 4 to the x. That is our basic equation. That has to go in this column here. Horizontally, is there a reflection? Yes, there is. Up here is the horizontal. That's our K value. Our K value is negative. That's horizontal. So yes, there's a reflection horizontally. Next, we look at vertically. That's our A value. A value is negative. That means there was a vertical reflection as well. So yes, there is both a horizontal and a vertical reflection. Next thing you're going to look at is whether there's a stretch or compress. So again, reflection has to do with whether the A or K's are negative. Stretch or compress actually has to do with the A and K values. In fact, not K, but 1 over K. Let's look at 1 over K. So our K is negative 2. 1 over K means 1 over negative 2. That means we're not looking at The negative though, so 1 over 2. 1 over 2 means that horizontally it must compress. So the graph horizontally compresses by a factor of 1 over 2. Now I want just an H there to remind you that it is a horizontal compression. So it comes across horizontally versus vertically. Now, let's check the vertical. Was there a vertical stretch or compress? Well, the A value is 1/3, just the number, not the sign. The number is 1/3. 1/3 means it's smaller than 1. That means it must have also compressed vertically. So vertically compressed by a factor of 1/3. And again, note, no signs are given, just numbers. The next thing we're going to look at is the translation. How does this graph translate? Means does it go left? Does it go right? Does it go up? Does it go down? Here we look at the D value. The D value here is opposite of what you see here. It's +1 here, so it's -1. So horizontally we're moving -1, which means we have to translate left 1 unit. The next one, down 1, we look over here. This -1 that's here on the outside means that the graph moved down 1. And that's what we have here. Now the asymptote. What kind of asymptote is there? Is it a horizontal asymptote? Is it a vertical asymptote? And that is a horizontal asymptote. The horizontal asymptote is at y equals -1. Y equals -1 means that the asymptote had to have moved down, which it did by translating down. So there's a horizontal asymptote at y equals -1. Next, domain and range. Domain is the horizontal. Now all basic table, so the basic exponential function has x belongs to real. Regardless of whether we flip, whether we stretch, compress, or move up or down, the domain for lucky for us, when it's x belongs to real originally, remains x belongs to real. That doesn't change, folks. But vertically, things change. The graph actually moved down 1. That means that the graph moved down 1 and it reflected vertically and horizontally. What does that mean? Well, when you flip an exponential horizontally first, it moves it looks like it flips over like a pancake. Now, we want to reflect it vertically. Well, vertically means that pancake flipped upside down. So much so that originally it started off greater than 0, but because we flipped it vertically, it now becomes less than what the asymptote is. So less than -1. So these numbers down here in green have to do with the basic. When we change the domain and range, it changes according to the information given. X belongs to real stayed the same because it doesn't change. Y belongs to real such that does change because it flipped vertically. Because it flipped vertically, you're going to have y is less than -1. All right. Example 2. What I want you to do is graph the transformations for y g of x equals -1/3 4 to -2x minus 2 minus 1. So we just did the description for that last one. Now we're going to do the graph. To do the graph, we make x have a coefficient of 1, don't forget. And then you're going to create a table of values by identifying the a, k, d, and c. So let's rewrite this a, k, d, and c in such a way that makes sense. So again, we write the a and the 1 over k, which is -1/2. And then d is going to be opposite of what you see, which is going to be -1, and c is going to also be -1. So now we can put that into our table. So we're going to complete a table of values. We're not going to graph it, we're going to complete a table of values. So here they are. Where did I get these values again? So here is you would put your basic, which we'll have in a second. But here specifically, how do we get these values? Well, remember, this is K, D, and this is A, C. 1 over K, D, A, C. 1 over K, D. I want to see, again, this reminds you, I want to see there's numbers here. I want to see numbers in the table and not just the general equation. So please make sure you put the right numbers where they belong. Next, we have our basic. Our basic is going to be y equals 4 to the x. And now what we're going to do is plug in our values. Our values are going to be -2 and 1/16. Where did I get 1/16? Again, 4 to the -2 is 1/16. -1 and 1/4. 0 and 1. 1 and 4. And 2 and 16. Don't forget the horizontal asymptote. Once you do that, you plug in the x values into the first equation and the y values into the second equation, and you will get the right values. -1/2 times -2 minus 1 is 0. -1/3 times 1/16 minus 1 is -49 over 48. And we do the same for the next set of values, folks. And we plug in the x and the y. So you need to be able to be quite comfortable with your calculator, especially that fraction button, because I'm notorious for those numbers. And then finally, our horizontal asymptote is going to be at y equals -1, because that's our c value. If you were to graph this, what you would have to do, folks, is convert all of the fractions to decimals to be able to graph. And yes, you are allowed to write this beside the table here, especially when you have to graph it. You are allowed to write that, folks. Okay, so homework, page 73, numbers 1, 2, 3, D only for 3, 6, 7, don't use the table, 8, 11B. If you use the table I gave you in this question, it'll be a lot easier to be able to answer the questions. All right, folks, have a numerical day. Take care.